In this video, we're going to learn how to solve equations using a graph, systems of equations using a graph. So first, make sure that the equations are written in slope, intercept form, and we might need to rewrite if necessary. You'd use your literal equation skills there. Slope-intercept reform, remember, is y equals mx plus b, where b is the y-intercept, and m is the slope. So the first thing you would do is graph the first equation, then you would graph the second equation, and the solution is where the two lines intersect. Remember, the answer must always be an ordered pair in the form x comma y. And it's very it's very important to graph your lines neatly. If you don't graph your lines neatly, it's going to be very difficult to see your solutions. All right. A system of equations can also have one of three numbers of solutions. So you could either have 0 solutions, you could have 1 solution, or you can have an infinite number of solutions. The number of places the two lines cross or intersect determine the number of solutions. So for example, in this first graph, these two lines intersect in exactly one place. That one's going to have one solution. And in particular, that solution is 2, 1, 2, 3, 4, 5. So that solution is at 2, 5. The second one, the two lines are parallel. So that one has no solutions. Those two lines are never going to intersect. So no solution. And again, that's because the lines are parallel. All right, this last one, notice we have two lines that are on top of each other, so they're actually the same line. And it's going to have an infinite number of solutions. They intersect along the line continuously. So this one is infinite solutions. And that happens when you have the same line. All right, so let's look at some examples. Example 1. Zoom in a little bit. I have y equals negative 3/2 x plus 2, and y equals negative 1/2 x minus 2. So these two lines are both in slope-intercept form, so step 1 is done for us. So now we need to graph it. Remember, we start at the y-intercept, so I'm going to start here at positive 2. And get a couple different colors, makes this a little easier to see. Start at positive 2, and then a slope of negative 3/2. So that means I'm going to go down 3 and to the left 2. So down 3 to the left 2. Down 3 to the left 2. And then I can go in this direction. I can go up 3. Sorry, that's not the left. I get my left and right confused apparently. This is down 3 to the right 2. And I'm going to go up 3 to the left 2. And that gives me all the points that'll fit on my graph. So we talked about how these lines needed to be graphed neatly, so you may want to take the edge of your agenda or the edge of a notebook or the edge of an index card to make sure that when you draw your line, it's indeed straight. Okay, so my second equation, I have y equals negative 1/2 x minus 2, so I'm going to go down to negative 2 for my y-intercept. And then my slope of negative 1/2 means I'm going to go down 1 and to the right 2. So I'm going down 1, right 2. Down 1, right 2. And then in this direction, I could go up 1 to the left 2, up 1 to the left 2, and that's all that's going to fit. So, draw my line. Connecting all my points together, and I look at where those two lines intersect. So they intersect at this point right here. So my solution would be 4, negative 4. And remember, we report our solutions as an ordered pair, 4, negative 4. All right, example number 2. Neither of those equations are in slope-intercept form, so my first job is to rewrite them. So my first equation is x plus 3y is equal to 9. And then I have 8x plus 3y is equal to negative 12. All right, so we have to solve for y. So in this equation, I'm going to have to subtract x from both sides to start. So I end up with 3y is equal to negative x plus 9. If I divide both sides by 3, I have y is equal to negative 1/3 x plus 3. So that's my first equation. Second equation, again, solving for y. So I would subtract 8x from both sides. So I'm left with 3y is equal to negative 8x minus 12. Double check, make sure you copy it correctly. Divide both sides by 3. And I have y is equal to negative 8/3 x minus 4. So now I'm set up, ready to graph. First equation, starting a y-intercept of positive 3, slope of negative 1/3. So I'm going to go down 1 to the right 3. And then on this side I can go up 1 and to the left 3. And that's all it's going to fit. Connect those dots together. All right. Second equation, y-intercept of negative 4. And I have a slope of negative 8/3. Now notice I cannot go down on my graph 8 spaces. So I'm going to have to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to have to go to the left 3. 1, 2, 3. And that's the only other point that'll fit on my graph. So I can take my straight edge, connect the 2 points together, and then I can read my point of intersection. So the point of intersection for those two is at the ordered pair negative 4, positive 4. Okay. Last example, I have 2 more equations, neither of which are written in slope-intercept form, so our first job is to rearrange those. First equation is negative 1 minus y minus 2x is equal to 0. So the easiest thing to do to solve this equation for y would be actually to add y to both sides. So I have negative 1 minus 2x is equal to y. Okay. I can actually flip this around. I have y is equal to negative 1 minus 2x. And then I can use commutative property, y equals negative 2x minus 1. So there's my first equation. All right, second equation, I have 2y is equal to negative 4x minus 2. Would have to divide both sides by 2. And I have y is equal to negative 2x minus 1. Okay, so I can go ahead and I can graph those. That one's showing up. And you'll notice something very interesting happening. So I go down to negative 1, slope of negative 2 means I go down to right 1, down to right 1, up to left 1, up to left 1, up to left 1. Draw my line. Same deal here, starting at negative 1, slope of negative 2, I go down to right 1 or up to left 1. I notice that my second line falls right on top of my first line. You all probably noticed that before I graphed it, but it kind of helps to have the visual. So if you notice the 2 lines fall right on top of each other, that means that there are an infinite number of solutions. So there are infinite solutions.